There are three types of chemical bonds, and the first one is shown here on this slide. It's what's called an ionic bond, and an ionic bond is essentially formed with something from the far left of the periodic table and something from the far right side of the periodic table. So when you look at your periodic table, the easiest way to notice it is when we look at the columns, those are what are called groups. So a group is a column. And this is also on your exam study guide. So if it's in group 1, 2, or 3, it's going to form an ionic bond with something from 5, 6, and 7. Notice that group 4 and group 8 are not combined, are not considered in this. So one of the best examples of an ionic bond is salt. We have sodium, which has one valence electron, and chlorine, which has seven valence electron. The whatever's on the right side of the periodic table basically has more what we call electronegativity. So that one valence electron is going to combine with the seven valence electrons for chlorine. So that now there's a net charge of negative on the chlorine side and a net positive on the sodium side. This forms what is a salt crystal, and you can see that shown in this image right here. We have sodium and we have potassium. So ionic bonds are formed when electrons are transferred. So transferred is the big keyword that you want to remember for ionic bonds. Ions are single atoms that have gained or lost electrons and become charged. So they're by themselves. So in solution, if we had a sodium ion in the blood by itself, it would have to have a positive charge because it lost one valence electron. If we had chloride in the blood plasma, it would have to have a charge of -1 because it gained one valence electron. Those are ions. But that's different than ionic bonds. Ionic bonds involve the transfer of valence shell electrons from one atom to another. The next type of bond is called a covalent bond. And covalent kind of looks like the word colleague, where you're sharing a workspace with someone. So think of the word sharing. In this case, atoms are sharing two or more valence electrons between two atoms. When they share two electrons, that results in a single bond. When they share four electrons, that results in a double bond. And when they share six electrons, that results in a triple bond. We're going to see that on the next slide. And this is involving mainly carbon. And when you look at your periodic table, you'll see that carbon is in group 4. So you should know how many valence electrons that means. Basically, whatever group it is in tells you the number of valence electrons. So if it's in group 1, it has one valence electron. If it's in group 2, it has two valence electrons. If it's in group 3, it has three valence electrons. If it's a group 4, like carbon, it has four valence electrons. If it's in group 5, it has five valence electrons. Group 6, six valence electrons. 7 is seven valence electrons. So for covalent bonds, it usually involves carbon. And there's two subtypes of these covalent bonds. There are polar and nonpolar. And we'll see that coming up. So the formation of covalent bonds are shown here. A lot of times they, like I said, they involve carbon and other atoms like hydrogen. Hydrogen is perfect because it only has one valence electron. And basically, since carbon has four valence electrons, it needs four in order to be stable, to meet that rule of octets. So here we can see that when it's sharing two, it's going to form single bonds. So in this case, this is a chemical called methane gas, CH4, and it can be drawn like this, or it could be drawn this way. You're not going to have to draw them out or anything like that. But the significance is, since it's sharing two valence electrons, it has a single bond. Other examples of covalent compounds are when we have the same exact atom. So if we have two atoms of oxygen, each oxygen is in group 6. So again, you know that means it has 6 valence electrons. And since each oxygen is going to share with each other, it does this so that now 4 total valence electrons are being shared, making a double bond between oxygen. In the case of nitrogen, nitrogen is in group 5. So if it's in group 5, you should know that that means it has 5 valence electrons. We see those 5 here. And what's going to happen is these electrons are going to share to form a triple bond. So remember, when there's a total of 6 valence electrons that are being shared, that is a triple bond. So let's look at the subtypes of covalent bonds. We have a nonpolar one and a polar one. The polar one is means that it's going to have a partial positive and a partial negative one. So this one is the classic example of polar. Water is always polar. And that's because this means it's partially negative, and partially positive. Now, it's not the same thing as an ionic bond because it's partial. This symbol here, which you're not going to have to know, but it means partial. So it's not like an ionic bond. In an ionic bond, it would be completely negative and completely positive. And the reason for that is the density of the electrons. In the case of a nonpolar compound, there's going to be equal sharing. So this is unequal sharing, and this is equal sharing here. So since oxygen is going to be on both ends of this molecule, oxygen, they're obviously going to have the same amount of valence electrons. It's in group 6, so it has 6 valence electrons. Whenever it looks like that, it's always going to be nonpolar. So this is a comparison between the two. This image, I believe, is in your book. Um, so these are the two main types of bonds. We're going to see the third type of bond called a hydrogen bond next. Hydrogen bond is the weakest type of bond. It's shown here, and we'll see an image of it on the next slide. But the ionic bond is a complete transfer of electrons, and it's attraction between two oppositely charged ions. So it has separate ions which are going to form if they were to separate, but when they're together, it's an ionic bond. The two subtypes of covalent bonds, again, covalent means sharing of electrons, but if it shares it unequally, it would be called polar. And the best example of that is water, has a partial positive and a partial negative end, whereas the nonpolar is equal sharing of electrons. And the example is carbon dioxide. Also, anytime it's the same exact atom bound to itself, so oxygen or nitrogen gas, all of those are going to be non-polar covalent bonds. The third type of bond, which we'll see on the next slide, is a hydrogen bond, and it's the weakest type of bond. It's an attraction between hydrogen atom carrying a partial positive sign and an electronegative atom with a slightly negative sign. So it could be the partial attractions between water molecules, as we see here, and we call that intramolecular bonds because it could be within a molecule or it could be between molecules. So in this case, it's between water molecules. But over here in the case of DNA, which we'll talk about at the end of this chapter, There are hydrogen bonds, which are between what are called nucleic acids. And you'll learn about what those are coming up. So all they are weak attractions.